Okay, so let me announce now last and probably also least the, the final intervention that is mine. So I think today was a very brilliant session. I think very different angles to tackle the decarbonization. My experience, I've been working for more than 20 years in the energy sector. I always work to protect fossil fuels. That was my job. So I defended coal plants, oil plants, gas plants. And then, I mean, in the last, let's say, 5 years, I changed my mind and I said, okay, maybe we need to embrace a change. So we did, together with Mario, the first concentrated power plant, the one in Sicily, when I was CEO in AD Power, which was the company owning the plants. And then when I moved to Dubai, we rejoined because probably the times now is mature to bring this technology to the market. So one question that I had is, what can we learn from the photovoltaic experience? And if we go to the first slide, please. So these are the real numbers. We all experience these numbers. Sometimes we forget because we live day by day in our reality. But the first curve is an exponential curve starting from year 2000, in which we had 1.5 gigawatt of photovoltaic installed. In 2023, the capacity was 1,600 gigawatt installed. You can do the math, it's 1,000 higher. So in 23, 24 years, we achieved this. The installed capacity in year 2000 was again 1.5. The installed capacity of gigawatt in photovoltaic last year was 350 gigawatts. So this is the meaning of an exponential growth. At the beginning, as you see, it seems that nothing is happening. So it took 10 years to get into the economics of photovoltaic. Nobody was believing in photovoltaic. Everybody said, okay, but we will continue with fossil fuels. Then some regulators adopted some incentives, some grants. And you see that the other curve is the cost curve. It moved for utility, that is 4 million per megawatt, probably was 5, 6 million. When I was working was 5, 6 million. So I was just ruling out the proposal of installing a photovoltaic. In 10 years, there was a decrease of 35, 40% of the cost. In 15 years, 75%. And sorry, it's not readable, but in currently, you know perfectly that to install is 600, 700,000 to install 1 megawatt is 85% less. But the interesting thing is that according to the renewable plants plan that everybody has after COP28, hopefully COP29, let's say in 2030, so in 6 years, the capacity will go to 7,000 gigawatts. So the exponential curve will follow that trend, and we will have 3, 4 times the capacity we have here. This means that, I mean, doing some calculation, that the cost will go down 90% compared to the initial 2000. And probably, as they say, renewable energy will be significantly cheaper than fossil fuels in 5 years. If you add CO2 certificates, I mean, fossil fuels are going to finish. And it means that the problem will be reversed to the TSO, to the transmission system operator, that will need to absorb incredible amount of intermittent energy from all over the sources. So this is the first lesson learned. If we go to the next. So let's apply this lesson learned to thermal energy storage. Of course, there are a number of topics. We saw from Breakthrough Energy, they are doing strong advocacy for regulators to say, oh, there are not only lithium-ion batteries. Lithium-ion batteries, they do power to power, so it's a different job. It's completely different business. This thermal energy storage is a game that converts electricity into heat, decarbonizing gas processes. So it's a huge change that was initiated 250 years ago, as I always say, from James Watt. So if we take the systemic analysis that I really recommend to read, it's a very good piece of work. they say that, let's say, by 2050, 3,100 terawatt hour of gas will be decarbonized at our range of temperatures. So it's not readable, but it's 3,100 terawatt hours, which is huge. The consumption of electricity in Europe is 2,500. So it's like decarbonizing more than Europe in the next 20 years. So if we project these numbers into the thermal storage situation, we see that now thermal storage is nothing. I mean, thermal storage is some nice demo plants, some initial projects of some $1 million. But if we believe that the same curve will be applied to thermal storage, the number that will come in 2050, so in 25 years, is like 120 billion cost of gas that will be completely replaced by thermal storage and hopefully green electricity. And being 100 billion every year is a huge impact on the market. Then, if we are, of course, able to introduce incentives, grants into the system quicker, faster, the projection of 3,100 will be achieved much in a small time compared to the 25 years. So this is a huge change in the market. I will say that, as we saw before, we know that photovoltaic got important incentives at the beginning, and the massive scale was then moved to China. So still now China is able to produce 200, 250 gigawatt of installed capacity annually. So they are a massive power. I mean, we are Italian technology providers. We defend our know-how, our values. It's important also to keep a balance in terms of where the technology comes from. So hopefully European Union, the US will push more. We see this because we are having a number of conversations with regulators to accelerate the curve for thermal energy storage. If we go to the last page. Prossima. So what are the lessons learned? So this is an exponential growth happening. Now probably the market is well below 1 terawatt hour. If we go to 3,100, it means 3,100 times what we have now in 25 years. So it's exactly the same situation that we had with photovoltaic. We saw the impact. It means that if this number becomes true, 30% of the gas will be replaced in industrial processes. So 30% of the gas is, as you can imagine, an incredible number that was consolidated in 100 years. So since the people start using gas instead of oil. So in 25 years, gas can be replaced 30%, and the future will accelerate as well, which means 14% of greenhouse emissions. So it's a big number. Of course, we need governments to contribute because this is not a technology that can go merchant against gas. Gas can always be moved, the price, by cartels. So if we want to have a strong push, we need the contribution from governments, and we are working all together with other technology providers, LDS, to bring this awareness. We need the cheap electricity, so the curtailment that Davide was mentioning, it's fundamental because probably we will have cheap electricity and sometimes even negative electricity to supply this machine. So it means that they will pay us to use this machine, which is good. Also for off-takers, of course, that they will reduce the cost of electricity and cost of gas. And finally, so electric thermal storage can be an answer to intermittency, but it's crucial to say that it's an infrastructure. So when you invest in infrastructure, you build a bridge between two mountains, you cannot expect to repay that incredible amount of engineering in 1 year or 2 years. Infrastructure are there to stay 50 years, 100 years. So these solutions are not plug and play solutions that can be replaced every year. When you install an MGTES, you are decarbonizing for 50 years, an industrial place, a hub. So it's infrastructure. And being an infrastructure needs to have a completely different approach from regulators, from, of course, technology providers, from the banks that will finance and go to bankability of these projects, and also from off-takers that will really need to believe into decarbonization, because otherwise it's quite possible that we stay with fossil fuels. They are there, they are okay, cheap, okay, they do some pollution, of course, but they are working. So if we want really to believe in decarbonization, we need to consider this kind of solutions, infrastructures that will contribute in the long term. I mean, in 2050, 2060, 2070, it will be a different world.